In this section, we're going to be focusing on the area of a few different kinds of polygons. We're going to look at parallelograms, triangles, and trapezoids. So first of all, we're going to talk about parallelograms. We've got a confidence statement written right here. I can calculate the area of a parallelogram. If you can't yet, you will be able to soon. So a parallelogram, just as a reminder, is a four-sided plane figure and in math, this is the way they say it's two-dimensional. They're not saying P-L-A-I-N like it's just plain, so regular. They're also not saying it's an airplane. They're talking about a plane as in a two-dimensional space. So it's a four-sided plane figure with opposite sides that are parallel. The formula for the area of a parallelogram is area equals base times height. A represents the area, B represents the base, H represents the height. And with parallelograms, as you can see, they take very different shapes. Yes, this is also a rectangle, but a rectangle is a parallelogram. Yes, this is also a square, but a square is also a parallelogram. But what's true with all the bases and height, no matter which parallelogram shape we're taking, is the base and the height are always perpendicular. So you notice we have a right angle showing in all of these. That helps us figure out where the base and the height can be found. Okay, so we know this is the parallelogram. The opposite sides are parallel, going the same direction. So the formula for a parallelogram is area equals base times height. And you don't have to write the dot like I've been doing, but you can. You can just write BH. Substitute the known variables. Okay, so notice the base and the height are where the perpendicular lines meet. So the base is this lower line, this bottom line, which is 6 centimeters. So I plug in 6 for the base. The height is the length of the line perpendicular to it. So the height is not 6. That's slanted. We don't want to use that. The height is 5 because that's the line that's perpendicular to that one. So we do 6 times 5 and we multiply and we get the area is equal to 30 square centimeters. Don't forget to use units when we're doing with area, and don't forget the units are always squared. So let's practice that here. Find the area of the rectangle, and a rectangle is a parallelogram because these two are parallel and these two are parallel. So area of the base is 4, area is equal to base 4 times height, 5.5. And 4 times 5.5 is 22. So the area is 22 square centimeters. Okay, now this is a great example because we often get it fixed in our head like the base has to be the bottom. Now, it often is, but does not have to be. Because if you think about this shape, I could have drawn this shape this direction and said 5.5 here and 4 here. And then we would have said, oh, well, the base is 5.5, the height is 4. And we would have gotten the same answer because multiplying, it doesn't matter what order you do it in. So it doesn't matter if you think about base as the bottom. The point is the base and the height are always perpendicular. So that's really the key to making sure you're using the correct numbers. Because frankly, since we're multiplying, it doesn't matter what order you put the numbers in. So since I see the right angle right here, I know this line and this line are the ones that matter. It really doesn't matter which one you call which. I'm going to call 7 the base because I think of this almost like it's a parallelogram on its side. But you don't have to think about it that way. You could say, well, 2 is the base and 7's the height. You'll get the correct answer either way. So I'm going to say 7 is the base, 2 is the height. So we get the area is equal to 14 square centimeters. So focus on the perpendicular part. Okay, now I'm going to do some more examples. If you feel like you've got this, I'd encourage you to jump forward to the next shape. But I'm going to do some more examples for those who want to see more. So again, on this one, the way they've drawn it, we want to focus on this line and this line because they're the two that are perpendicular to each other. So I'll say the area is equal to 6 times 7. 6 seems to be the base, 7 seems to be the height. Or you could say it the other way, doesn't matter. 6 times 7 is the same as 7 times 6. So we get 42 square meters. Okay, on number 2, you could think that, okay, well, this is a right angle, so is this one. But even if you didn't think about it that way, you should be able to tell by looking at this is a square. So if this side is 4 centimeters, this side is also 4 centimeters. So in this case, the base and the height are the same. So you can just say A equals 4 times 4, get 16 square centimeters. Okay, on number 3, we have a right angle, right there. So this is the side that matters, 3.5 feet. And this side matters, 9 feet. And 3.5 times 9 is 31.5 square feet. Okay, 4 is also a parallelogram. It's also a rectangle. Base times height. So our base is this right here, 2.5. Our height is right here, 5. 2.5 times 5 is 12.5. So the area is 12.5 square yards. Okay, so you guys have to do projects in school all the time. So Cindy is making a display for a project. She plans on placing 100 stickers that are 2-inch by 2-inch squares on a poster board. I recommend when they don't draw pictures, you do draw some. So 2 by 2-inch stickers, 2-inch by 2-inch. The poster board she's using has a length of 3 feet and a width of 2 feet. Does she have enough room for all of her stickers? So we have 2 different kinds of parallelograms, but they're both parallelograms. One's a rectangle, one's a square. But we can find the area of each one and figure out, is there enough room on this poster board for 100 of these stickers? Now they did get tricky on us, and they're doing different dimensions. So what I would going to choose to do is change these to both be inches. So 2 inches by 2 inches is fine, but 3 feet, 3 times 12 is 36. 2 times 12 is 24. So the area of one sticker, base times height, gives me 4 square inches. Now there is 100 of those though, so 100 of those, have to multiply by 100. The stickers are going to take up a total of 400 square inches. So that's the sticker area. Now to figure out the area of the poster, we'll do base 36 times height 24, because we're converting it to inches. And when you multiply those together, you get 864 square inches. So good news, Cindy, there's definitely enough room on this poster for all your stickers, because the poster has 864 square inches. The stickers only take up about half that space, 400. Okay, here's an area. Here's a place sports comes in. So the area of a basketball court in the NBA is 4,700 square feet. The court is 94 feet long. What is the width of the basketball court? Okay, and since we're dealing with a rectangle, you can really think of it as length times width or base times height. It doesn't matter. Now, when a parallelogram is shaped like this, calling it base times height is significant. But when you have a square or a rectangle, length and width, base and height, they can really be interchangeable. So we'll just use area equals length times width, since that's the one, since they called it width. in length. So we need to plug in what we have. It's good to remember these are equations, so there's really two sides of it. Everything we've done so far, we got these two pieces and found the area. But this time they're telling us the area, 4,700 square feet, and then the length is 94. What we don't know is the width, the W. So once you plug these in, hopefully it's easy to say, oh, okay, I've got to solve for W. Well, right now, W is being multiplied by 94, so I need to divide both sides by 94. So we do 4,700 divided by 94, and turns out that is 50. So the court is 50 feet in width. Okay, dealt with parallelograms, now we're going to deal with triangles. Again, confidence, I can calculate the area of a triangle. And if you can't, you'll be able to soon. Okay, so a triangle is a plane figure, meaning two-dimensional. A plane figure with three straight sides and three angles. The formula is one I'm sure you've done before. It's half times base times height. I'm going to use this version most of the time because this is the one you'll see throughout high school when it's written. Now it is the same as doing base times height divided by 2. So if you find it easier to work with it that way, I'm not going to fuss about whether you use this method or this method. It's totally fine to say base times height divided by 2 because multiplying by 1/2 is the same thing as dividing by 2. So I'm going to use this method, but you're welcome to use this formula instead. They are identical. So A represents the area, B represents the base, and H represents the height. So it's really identical to the parallelogram formula, except you're multiplying by 1/2. Or if you prefer, think of it as dividing by 2. And just like it was with the parallelograms, the base and the height are always perpendicular. Okay, so first we'll just try to practice knowing which one is which. So in this triangle, we know it's got to be this line and this line we're concerned with because that's where they're perpendicular. Because perpendicular means you form a right angle. This is the base. This is the height. Okay, now I want you to notice, it's hard to tell, but this right here is a dotted line. This right here is also a dotted line. So it's this that I'm highlighting, this is the actual triangle. That's the actual triangle. So the base is what's highlighted here of the actual triangle, that side. And the height is this dotted line over here. So there are times when we have an obtuse triangle like this, the height is actually found outside the triangle because we've got to form a perpendicular line. Or when you have a right triangle, you can say this is your base, this is your height, because these two sides are perpendicular to each other. And when it's shaped like this last one, it helps you just think of it this way. They just turned it kind of lopsided, and this is your base, and this middle line is your height. So this first one and this last one are very similar. They've just rotated the triangle to be facing a different direction. Okay, so number one, we know the formula is area equals 1/2 times base times height. So I do 1/2. The base is 5. The height is 4. And you can type all this in your calculator. If you're trying to do it by hand, I'd recommend when you can, multiply the even number, if there is one, by the 1/2. Because half of 5 is 2.5, and that's not as easy in your brain to say 2.5 times 4. But if you say half of 4 is 2, 2 times 5 is 10, tends to go quicker. Okay, on number 2, our base is 6, our height is 4, so we get the area equals 1/2 times the base 6 times the height 4. Half of 6 is 3, 3 times 4 is 12, so it's 12 square centimeters. Okay, on this one, the base is 7, the height is 5, so I get 1/2 times the base times the height. So if you're able to do this in your head, great, but it's okay if you need to use the calculator because there's no even number to make the 1/2 easy, and that to be true even if you're using the method where you divide by 2. You can end up with some decimals regardless. So it turns out this time the area is 17.5 square centimeters. Okay, number 4. Again, you can almost think about this like it's on its side. So you can think, okay, this is my base, the 9. This is my height, the 2. So the height is 2, the base is 9. So I'll do area equals 1/2 times the base, which is 9, times the height, which is 2. So 1/2 of 2 is 1. 1 times 9 is 9. So the area is 9 square meters. Okay, if you feel good about this, I encourage you to skip forward to the last shape, the trapezoids. But if you want to see more practice, I'm going to do the rest of these problems. We'll do area equals 1/2 times the base, 4, times the height, 4. 1/2 of 4 is 2. 2 times 4 is 8, so we get 8 square centimeters. Okay, this triangle is kind of flipped upside down, but this is its base. This is its height. So we do 1/2 times the base times the height. 1/2 of 4 is 2. 2 times 9 is 18. So we get 18 square inches. This one's also kind of flipped upside down. I would say the base is the 12, the height is the 17. But again, if you decided to think of it more like this is the way it's oriented, if you called this the base and this the height, it's not going to cause a problem because it doesn't matter what order we multiply things in. So if you call this one the base and this one the height, you'll still get the same answer I'm getting with the way I labeled them. So we do 1/2 times the base, 12, times the height, 17. 1/2 of 12 is 6. 6 times 17 is 102 square feet. Okay, on this one, the base would be this 12 feet right here. The height would be the 8 feet that's forming the perpendicular line. So we would say the area equals 1/2 times the base 12 times the height 8. 1/2 of 12 is 6. 6 times 8 is 48 square feet. Okay, Tim is building a birdhouse. One wall is shaped as a right triangle. The dimensions of the wall are pictured. What is the area of this part of the birdhouse? So we're doing the same thing here, but this is something that gets used when you're doing construction. You're trying to figure out how many square feet you want in a real house or a birdhouse, either way. So we have area equals 1/2 times the base, which is 12, times the height, which is 7.5. 1/2 of 12 is 6. 6 times 7.5 is 45 square inches. A triangular road sign has a height of 3 feet and a base of 2.5 feet. So I'm going to go ahead and just draw this. Doesn't matter what the triangle looks like as long as I get the base is 3 feet, the height is 2.5 feet. How much larger in area is this sign than the one with a height. Oh, I did this backwards. Okay, so this is actually our second sign. Base of a triangle. Let me try this again. A triangular road sign has a height of 3 feet and a base of 2.5 feet. So that's the first one right there. How much larger in area is this sign than the one with a height of 2.5 feet and a base of 3 feet? Well, let's just write the formulas for this. This one we do half times the base, 2.5, times the height, 3. And for this one, we do half times the base, 3, times the height, 2.5. Now, some of you, I think, can already see where this is going, because if you notice, these are the exact same numbers. And as I've already talked about, when we multiply, it doesn't matter what order you multiply them in. You multiply these three together, you get 3.75 square feet. Multiply these two together, you get 3.75 square feet. So if the base and the height are the same numbers, doesn't matter which is which. It's going to have the same overall area. And our last shape in this section is trapezoids. So the area of trapezoids, again, we've got a confidence builder. I can calculate the area of a trapezoid. A trapezoid is a plane figure with one pair and only one pair. So I'm going to say with exactly one pair of parallel sides. And that can be the bottom and the top, like you see in these two, in this shape. It can also be the left and the right, which you see in this shape. Now, whether they're top or bottom, left or right, anything that's parallel in trapezoids, that's called the bases. So you might remember in parallelogram, it didn't really matter which we called base or height, or maybe it was more so in triangles. But anyway, regardless, here it is going to be important you label things correctly. The formula for the area of a trapezoid is 1/2 times the height times base 1 plus base 2. So this little 1 and little 2 is just saying make sure you get both bases, because as you can hopefully tell, they're going to be different lengths. So that one's smaller, that one's longer. This one's smaller, that one's longer. A represents the area. H represent the height. And B1 and B2 represent the lengths of the parallel bases. And as always, or at least in this lesson as always, the bases and the height are always perpendicular. So let's just practice labeling. And it doesn't matter which one you call base 1 and base 2. As long as you're labeling the bases as bases, it's fine. It doesn't matter if I call the top B1 or the bottom B1 on this first one. So I'll just say base 1, base 2, and the height is this dotted line. Because I know it has to be perpendicular, so you look right there, perpendicular. Okay, now these are parallel on the sides, so this is base 1, this is base 2. So that makes this what we need to plug in as the height. If it helps, you can think about that one almost as though it's been turned on its side. This one, we'd say this is base 1, this is base 2. This dotted line that forms a perpendicular line, the right angle, is the height. So now let's use that to help us actually work some out. So find the area of the trapezoids. So I'm going to start by writing the equation. 1/2 times the height, base 1 plus base 2. Okay, so up here is base 1, down here is base 2, and this is the height. So I'll do 1/2 times the height, which is 4. And it doesn't matter what order you put these in. So the point is 3 plus 5, 5 plus 3, you get the same result. So half of 4 is 2. 3 plus 5 is 8. So we get 16 square centimeters. We have base 1, base 2, and the height. So 1/2 times the height, base 1 plus base 2. Half of 5 is 2.5. Use your calculator if needed. 4 plus 7 is 11. 2.5 times 11 is 27.5 square feet. Okay, here we got to make sure we know which are the bases, which are the heights, because this time they give us 4 numbers, not just 3 like they did up here. So the 2 parallel sides are the bottom and the top. So this is my base 1, this is my base 2, and this is my height. So I'll do 1/2 times the height, which is 6, times base 1 plus base 2. Half of 6 is 3. 6 plus 8 is 14. So we get a total of 42 square centimeters. Oh, look at this. Here on number 4, we've got 5 numbers, so we got to be really careful. Let's think about bases first. So bases have to be parallel. That is going up and right. That is going down and right. So those are not parallel, but the top and the bottom are parallel. So the 7-inch and the 10-inch are the bases. And the height has to be perpendicular to those bases. So that means we got to look at this dotted line where the 4-inch is, because it's the one that forms a right angle with the 2 bases. So the 5s in this case just end up to be extra information, just like the 4 was back here. It's true info, it's just not needed. 1/2 times the height, which is 4, times base 1 plus base 2. Half of 4 is 2. 7 plus 10 is 17. So we get a total of 34 square inches. So like I said with the other shapes, if you feel like you understand it from here, I think you've watched enough. If you need more practice, I am going to finish the other examples on the other page, but I'll go a little more quickly through them. Or the second half of the page, I should say. So 1/2 times the height, which is 12. Base 1 plus base 2, 9 plus 18. Half of 12 is 6. 9 plus 18 is 27. So we do 6 times 27 and get 162 square centimeters. And if I'm writing too fast, feel free to pause before I go to the next one. Okay, here the bases are the left and the right, just like it was on number 1, because they're the ones that are parallel. So my height is what's perpendicular to those 2, which is the 5 feet. So the height is 5, base 1 plus base 2. Half of 5 is 2.5. 5 plus 7.5 is 12.5. And if we multiply those 2 together, we get 31.25 square feet. Okay, 3 bases are 8 and 15. The height is 7. So half of 7 times base 1 plus base 2. Half of 7 is 3.5. 8 plus 15 is 23. 3.5 times 23 is 80.5 square meters. Here we get half times the height. And then the bases are the top and the bottom because they're the ones that are parallel. So we'll do 8.5 plus 13. Half of 5 is 2.5. 8.5 plus 13 is 21.5. And when you multiply those 2 together, you get 53.75 square inches. Now these last 2 are more word problem-like, so I'll work through them. We'll work slowly. The side of a goal in soccer is the shape of a right trapezoid. So just to understand what they're talking about, it's a right trapezoid when the height can be found as an actual side. Because if you think about it from this orientation, then one side is completely perpendicular to the two bases. So this is a right trapezoid, whereas these two are not. Because to find the height, we had to do dotted lines. The sides themselves did not form right angles. As we look at these four, this is the only one that's a right trapezoid because its side is actually the one perpendicular to the two bases, whereas that was not true in 1, 2, and 4. So on this, which again, this is a soccer goal. So if you're trying to visualize it, like the goalie would be right here, trying to block the ball from going in the net. So this is the side of it, and this forms a right angle right here. So this is a right trapezoid because this side, the part of the goal, the pole, that's what I wanted, that the goalie has to make sure doesn't run into, is perpendicular to the ground, which is where one of the bases sits. So what is the area of the net needed for both sides of the goal? So we'll first find the area of this side of the goal. Then we'll double it so we know the area of the side that's over here. We can't see quite as well. So area is half times the height, which is 8, times base 1, base 2, 10 plus 4. So I got the height is 8, the two bases are 10 and 4. And you can say 4 plus 10 or 10 plus 4, makes no difference. Half of 8 is 4. 10 plus 4 is 14. 4 times 14 is 56. So one side would need 56 square feet. Just this side, which is closer to us, would need 56 square feet of net. But we've got to double that because there's two sides. That's why it says both sides. So 2 times 56 gives us 112 square feet. Okay, Quinn is building a table. The top is an isosceles trapezoid. You don't have to remember what isosceles trapezoid means, but let's see. None are clearly labeled on this one, but isosceles would mean the two sides that are not the bases are congruent. So if we had one shaped kind of like this side and this side are congruent to each other. That, if you remember, an isosceles triangle means two sides are equal. An isosceles trapezoid is similar, means two sides are equal. You will not have to remember that for the sake of art class, but that's what they're talking about. So the bases are 1.5 meters and 2 meters, and the height is 1 meter. So what is the area of the tabletop? So 1/2 times the height, which is 1, times base 1 plus base 2. Half of 1 is half. 1.5 plus 2 is 3.5. And half of 3.5 is 1.75 square meters.